Today's technical webinar is about user-tailored privacy for total learning architecture. Our speaker is Bart Knijnenburg, an assistant professor in human-centered computing at Clemson University. This is part 2 of a 2-part series, but if you missed last week's session, no worries. Bart will catch you up. The session this week is focused on the potential implementation of user-tailored privacy in TLA and other advanced distributed learning systems. Bart will be speaking for about 45 minutes, maybe a little bit less, and there will be time at the end for him to address your questions. He'll try to his best to get to as many questions as possible within the allotted time. To ask a question, you can click on the questions panel in the GoToWebinar window and type your question there. This webinar will be recorded and we will distribute a YouTube link via email in case you would like to share it with your colleagues. Without further ado, I'd like to introduce our speaker, Bart.
Thank you. Well, welcome everyone to this webinar on user-tailored privacy. As Liz already told you, last week we gave you an overview of this novel means of protecting privacy, and today we'll talk about how to implement user-tailored privacy, at least in broader terms, for distributed learning systems like the total learning architecture. Again, don't worry if you missed last week. I'll briefly go over the main points again. For a more in-depth treatment of the general topics, feel free to refer to the previous webinar, which will be online soon. So let me make sure my clicker works. Yes. My name is Bart Knijnenburg. I'm an assistant professor in human-centered computing in the Clemson University School of Computing. My research interests are in usable privacy decision support and user-centric design and evaluation of adaptive systems. And so I'm really excited to talk today about user-tailored privacy because it really nicely falls on the edge between these two different fields of areas of expertise of mine. I also have 2 of my students in the room who will manage the question answering during the talk. So if you do have questions during the talk, feel free to already ask them. They will try to answer the ones that are easy to answer on the fly, and they will reserve the more complex ones for the end of the presentation. Now, before I start, I want to acknowledge the fact that this work. The work behind this webinar, as well the webinar itself, has been graciously supported by a DoD award for the Advanced Distributed Learning Initiative. But to also note that the views expressed in this webinar are those of myself, and that they don't necessarily represent the views or policies of ADL or the Department of Defense. So today I will explain how user-tailored privacy can serve as a model to alleviate the privacy concerns of users of distributed learning systems like TLA. Now, this webinar and the one last week were based on a comprehensive report on user-tailored privacy that I wrote for ADL, and you can find this and other reports on the website listed over here. I will also make sure that the videos, once they come online, as well as the slides of the webinar, are available through this link as well, and that holds for both this week's as well as last week's webinar. So here's a one-slide takeaway for this webinar in case you need to drop off at any point during the webinar. So the one-slide takeaway here is that learning systems that employ TLA, but I would argue most modern learning systems, are envisioned to use a lot of learner data to provide a personalized learning experience. And so the power of TLA lies in the effective use of this data for personalization purposes. But one must acknowledge that this data collection may also lead at sometimes to privacy concerns. So the goal of user-tailored privacy is it's one way of alleviating these privacy concerns. And the specific way in which user-tailored privacy does this is actually quite reminiscent of how learner modeling works. Namely, you measure the user's privacy-related characteristics and behaviors. then you model their privacy preferences based on this input, and then you adapt the privacy settings of the learning system according to this user privacy model rather than the learning model, the user privacy model that you create of the user. So that's what we're going to talk about today. How do you build this for a TLA-based learning system? So today we will start by making a case for user-tailored privacy. We'll make a bit of a definition of user-tailored privacy, explain what the different components are, and then we will go into each of these components of measuring, modeling, and adapting privacy in more detail. So I'll start with explaining why we want to do user-tailored privacy. Why is this important, especially for distributed learning systems like TLA-based systems? So if you're a developer building a learning system, you are probably already familiar with technical solutions for privacy protection. And these technical solutions are great, but they have certain shortcomings, especially in the context of learning systems. For example, the idea of having a distributed architecture for data management actually fits quite well within the concept of distributed learning, but the idea of distributed learning is usually to have some kind of a meta recommendation level where some overarching system recommends different learning activities or applications to be used. And so this overall recommendation architecture, in order for that to work, a distributed data management architecture is actually counterproductive, right? Because then the data lives in too many different places and needs to be sent over the network, which is unsafe in and of itself. So that doesn't really work very well for such a system. Likewise, another typical technical solution to privacy is to anonymize data or to use pseudonyms in your system. And pseudonyms work quite well in, for instance, chat forums or systems like that. But for learning, pseudonymity is not always desired. For example, if you want to credit someone for the learning that they did, then you need to know their actual name, because this credit needs to go on their official record. So pseudonymity is not really very well possible in a learning system like that. And I've talked about these shortcomings in more detail in the previous webinar, but the takeaway from this is that we need to complement these technical solutions with some sort of privacy settings, right? Because different users are going to have different preferences on how to deal with their privacy, and these technical solutions won't be able to protect all of their data. So in the end, it's still a user trade-off between data collection on the one hand and privacy on the other hand. So the problem is that privacy settings, the concept of privacy settings is somewhat problematic, especially in very complex systems. And I would consider that most modern learning systems, including TLA-based systems, are actually fairly complex from this perspective. The problem with privacy settings is that even though users usually argue that they want to take control over their privacy, they actually, when you give them that control, they actually don't always take control. And because of that, control actually does give people some sort of confidence, but if they then don't take that control, then that confidence is kind of misplaced. So just giving people control can give the impression that people can deal with their privacy, but they don't always do it. Another thing is that control needs to be understood, right? People need to understand what they're actually doing when controlling their privacy settings. And some research has shown that, for instance, on Facebook, more than 70% of people don't understand their own privacy settings. And so this means that you need to explain these privacy settings to them. But these explanations, if you want to give people meaningful explanations of their privacy settings, usually in most modern systems, those explanations are so complex that people either don't bother reading them, or that it just takes too much effort to carry carefully read these explanations, these notices. Another problem there is that even if you force people to really read these privacy notices, their effect is actually rather fickle and fleeting. Usually after a minute, they've already forgotten what's really in these policies, even if you ask them to read it very carefully. And then finally, even if you get people to actually make informed or what you would hope would be informed decisions regarding their privacy, it turns out that these decisions are not always rational, and they're actually influenced by external influences that shouldn't be influencing their privacy decisions. And so because of this, in modern information systems, including most modern learning systems, the idea of giving people notice and choice of having to manage their own privacy through settings is somewhat unrealistic, because it's just too complex for people to deal with. So as a solution, we need to go to something that's a little more user-centric, that's a little more usable, a little more user-friendly. And so two approaches that I advocate for TLA are privacy by design and user-tailored privacy. Now, privacy by design, the idea behind privacy by design is to build privacy principles right into the core of the systems. So rather than just tacking on a bunch of settings at the end of the system development, you really think about what are the best privacy practices as you are developing the system. Now, I don't have a lot of time today to go into detail on privacy by design, but I organized a series of webinars last year on privacy by design specifically for TLA. So the slides and the video of these webinars, it's a series of 3 webinars. They're actually online on the website that I pointed out earlier. So if you're interested in applying privacy by design in a TLA-based system, then I really encourage you to check out those webinars. Now, as for user-tailored privacy, the idea of user-tailored privacy is to give users control over their settings, but to do it in a way that is manageable and personalized. So rather than overloading the user with many different controls that they have to manually set one by one, what we do is we personalize some of these privacy settings. We take over some of that control, make some of those settings based on this privacy model that we create, and only selectively present certain privacy settings to the user to make themselves. So it kind of makes a trade-off between it reduces the burden of privacy decision making while at the same time keeping them to a certain extent in control. A nice added benefit here is that by modeling users' privacy preferences and by reacting to those models, we can also include in those models not just the user's preferences, but also the constraints and practices of the organization in which the user operates. So we can actually take into account more than just the user's preferences. And this will come up at other times during this presentation as well. So that sounds like a good idea, but how do we do it, right? How does it work? How does user-tailored privacy really work, and what does it do? So user-tailored privacy-based systems, what they do is they first gather some input data. And they do this by measuring the user's privacy preferences, by observing their characteristics and their behaviors. So preferences are being measured by observing the user. And then these observations are used to model the user's preferences in a context-relevant manner. And the context here is very important, because it turns out that privacy preferences crucially depend on who is requesting the information and what information is being requested, and what is the situation in which that information is being requested. So that needs to be part of this model. And then finally, user-tailored privacy-based systems may make supportive adjustments to the system, personalized adaptations that help the users in achieving the privacy preferences that are modeled. And this can be in terms of direct changes to their settings, or in terms of recommendations for changes to their settings. potentially with some justifications for why changing those settings would be useful for them. Here's just a visual representation of this idea. Follows a typical user modeling framework of measure, model, and adapt. And we will go over each of these topics one by one later in the webinar. Now, before we do that, I want to recognize that especially within a complex environment like a learning system that is based on TLA, user-tailored privacy can actually support several different goals. And the most straightforward goal here is to support the user, right? And one way to do this is by automatically acting on their behalf. So as the automation is, as this automation usually happens outside of the user's awareness, one way to kind of bring the user back into the loop is to implement what I call tailored awareness, to inform the user about key privacy decisions that are being made on their behalf, in which they have specific interest, and so that they can, for one thing, be aware of those settings that are being made, but also to make adjustments if they want to change these settings a little bit. And the latter is really important, especially because this user-tailored privacy system is supposed to trade off these conflicting goals of a TLA user. Because on the one hand, they want adaptive learning, that's why they're using a TLA-based system, but on the other hand, they want privacy. And for the one day, the system will require more data, and for the other, they will want to disclose less. So UTP needs to make that, user-tailored privacy needs to make that trade-off, and needs to find that balance, and there is some input from the user is required. It's just that we don't want the user to have to do all of this themselves, right? But we can go a step further in bringing the user into this loop, right? We can actually try to teach the user about their privacy. So I like this idea because it's in line with kind of the general philosophy of a learning system. Why not teach the user something about privacy while they're using this learning system, right? So to do this, one thing you can do is, rather than setting privacy settings automatically, you provide tailored guidance. So you make suggestions or changes in the user interface that will help the user accomplish their privacy-related goals in a more user-friendly manner, rather than taking over the decision as a system, really helping the users make these decisions themselves. And you can take this a step further towards explicit education, where you literally try to teach the user something about privacy. Now, privacy and security education already exist. The idea behind user-tailored privacy is that you can acknowledge and model the interests and the knowledge of the user as part of this process, right? So there's no need in teaching users something about privacy they already know. It's also not important, not really useful to teach them something about an aspect of privacy that they apparently don't really care about. But aspects that they don't know enough about, that they might actually find very useful and interesting, that's something where you can provide some interesting education. So that would be another aspect of user-tailored privacy, is to provide tailored education about privacy. Now, obviously, in this process, it's important to reconcile the burden of taking control and being in the loop with the control that people may still want to have. So you need to provide a certain amount of control that is not too much of a burden, but not too little to leave them completely out of that loop. So that's a little bit of a tricky balance to make. Another goal that can be accomplished with user-tailored privacy, and this is along the lines of those organizational constraints and practices that I mentioned before, is to encourage the disclosure of information that is of particular usefulness to the overall mission of TLA. And we've identified this as being improving the personalization of the system, educational research, helping educational research, and informing personnel-related decision-making. Right? So for each of these components of TLA, a certain amount of information from its users is needed. And so a user-tailored privacy-based system can particularly try to convince the user to provide the type of information that is useful for attaining these goals. Of course, it's important in this process to really keep in mind the user themselves and to really make the learner the main component of that decision making, and to really try and find to navigate this disclosure discussion, to find ways to get to the information disclosure that learners do to benefit both them and the system. And so this can be done with a technique called multi-stakeholder decision making. So there are various algorithmic techniques that can be used to actually kind of trade off the different preferences of different stakeholders in the decision, and they can be automatically applied within user-tailored privacy as well. So in sum, user-tailored privacy can help TLA to maximize the benefits of a personalized learning experience without increasing users' privacy concerns. And when the way you can do that is by when you are recommending a learning activity to a user, the TLA-based system can employ user-tailored privacy to make sure that the overall privacy practices of the learning activity provider actually match the user's privacy preferences. If the user's privacy preferences are more stringent than the policies of that application, then we can refrain from recommending that application. But once we have found an application that matches the user's privacy preferences, that application can then be recommended to the user, also based on other considerations, obviously. And then when the user starts using that system, user-tailored privacy can also support the user in setting the privacy settings within that learning application to also match the user's privacy preferences. Now, in order to accomplish this, I believe that TLA should have some kind of a privacy API. And this privacy API can expose the privacy practices of a learning application in machine-readable format so that the user-tailored privacy component can kind of compare that and reconcile that with the user's privacy preferences. And this privacy API can also allow some sort of external control over the privacy settings of the application, so that user-tailored privacy can also automate that process of making these settings within each learning application. The other aspect of user-tailored privacy that it can assist TLA is in the management of privacy in social learning experiences. And social learning experiences are likely to become part of TLA as well. Now, it's important to note when we think about social learning experiences that the users of social network technologies tend to employ a selection of strategies to defend multiple privacy boundaries. So they have different ways in dealing with privacy. And this may include both the disclosure or withholding of information, but it can also include things like audience selection and blocking and limiting communication, like straightforward communication between people. Or, for instance, the selection of co-learners and learning groups in which they want to operate. So this means that there's various ways in which people can deal with social learning privacy. This can get very complex. And it's not a good idea for these privacy management strategies to have to be applied over and over again with every single social learning application. So instead, I think it would be a good idea to develop some sort of a social learning API for TLA as well, where the sharing and communication preferences of each user become kind of persistent across all the learning applications that are part of TLA. And so this avoids having to manage these interpersonal boundaries separately for each individual app. So now I will take some time to explain each aspect of the user-tailored privacy framework in the context of the total learning architecture. I'll talk about measuring, modeling, and adapting privacy. And I'll start with measuring privacy. So the most important takeaway here is that in measuring privacy, context really matters. The challenge here is to get a complete understanding of the context in which a privacy decision is made. And this includes both the type of information requested, the person who is requesting the information or the entity who is requesting the information, and the socio-technical situation in which the disclosure takes place. So as for the type of information that's being requested, I strongly encourage that the developers of TLA-based systems really take some time to study users' privacy behaviors to provide a good basis for user-tailored privacy. One of the findings in privacy research is that the sensitivity of different types of information really differs and really varies per type of information, right? So this suggests that there's not just a single concept of privacy concern or disclosure tendency that needs to be modeled as part of user-tailored privacy, but rather that there are a number of privacy dimensions that each have to be tracked simultaneously. So as an example of this, here are 15 different items that one can disclose on their Facebook profile. And a friend of mine asked about 200 Facebook users how likely they were to disclose each of these pieces of information publicly. So set these things open to all. And so I analyzed his data, and I used the dimensional reduction technique of factor analysis. And I found that the data actually consists of 4 different dimensions. So you have Facebook activity, which includes things like wall posts and status updates, so things you do on a daily basis on Facebook, so to say. Location, which is hometown, city, and state. Contact information, which is your actual address, phone number, and email address. And then personal interests, things like religious views, likes, and Facebook groups. Right? So a similar study would be very useful in TLA-based systems to see which privacy settings conceptually coincide with each other so that they can be modeled together while having these different groups of privacy settings still modeled conceptually separately within your privacy model. Now, once you've established these various privacy dimensions within your application, you will find that users don't just differ arbitrarily on these dimensions, but rather that they are clustered into a number of what I would call privacy profiles. And these profiles are likely to exist because of cultural, demographic, and personality differences that exist between users. And because they are based on these individual differences, they may actually, with some caution, be able to extend to other audiences and other situations as well. So I'll give you an example of this. So first of all, here's an example of some of these different privacy profiles, specifically for Facebook. So we have developed this technique for creating these privacy profiles based on collected data. And we find that users can be characterized for this particular set of data with 6 profiles. And so aside from privacy maximizers who do a lot of these different things and privacy minimalists who engage very little in privacy settings, we have a group of selective sharers who share a lot of information, but they carefully decide what to share with whom. On the other hand, we have self-censors who share with everyone equally, but they limit the amount that they share. And then we have time savers who primarily manage the incoming information to prevent information overload. So whatever they receive from others in terms of chats and posts, etc. And then finally, privacy balancers who do a little bit of everything. So as I mentioned, you can create similar profiles by collecting data in your learning application, but you could potentially also learn from these existing profiles by abstracting away from their original application to try and get to the underlying motivation of the people who employ these different profiles, right? So we tried to do that for TLA based on the profiles that we developed for Facebook, and we found we came up with the following ideas. So, for instance, for selective sharers on a TLA-based learning system, we argued that they would require some sophisticated functionality to curate and selectively share their personal information and training outcomes with different types of people. So with different groups of people, they want to share different things. For self-censors, it would mean that they need a mechanism to limit the amount of information that they would share. So they would still maybe want to share their learning outcomes, but at a very high level, maybe their overall progress or just pass-fail, but not their exact behavior within a learning application, right? Then for time savers, you would want to have some way for them to opt out of learning notifications because they don't want too much incoming information, and to maybe opt out of the social learning features. They want to maybe learn on their own without being bothered by other people, right? Privacy maximizers obviously need all of these different functionalities, but it's important to note here that you probably only want to provide literally all of this functionality to the privacy maximizers, because if you provide all of these different functionalities to other users as well, they will likely become overwhelmed by the different privacy features available. And we see this happening on Facebook, where there are so many different ways in which you can manage your privacy that people easily become overwhelmed by what is actually there, right? And in consequence, a lot of people don't end up using any of these. So that's an ironic consequence there. Privacy balancers are a little bit more difficult to deal with because they do a little bit of everything, but as long as you have some mechanisms for curation, blocking, and avoiding direct interaction, you're probably good. And then privacy minimalists, for those it's inversely very important to make sure that they can give applications and other users unrestricted access to their data so that they can maximally benefit from all the functionalities that TLA has to offer. So while we are providing all these privacy functionalities for other users, we need to acknowledge that privacy minimalists may want to be able to share as widely, as broadly as possible. Now, another aspect of measuring privacy is to keep track of who is the recipient of the information. So users' privacy concerns and behaviors tend to substantially differ depending on who is the recipient. And again, some patterns here are discernible, which means that recipients can be classified into groups, or what Google has called circles, right? Different groups of people, or in some cases, applications. Now, these groupings likely exist, again, due to some kind of trust-based relationships. And because of that, again, it's maybe possible to, with some caution, extend some of these findings that we have done in, for instance, social networks to learning systems. But it's obviously better to develop these groupings in the application that you yourself are developing. So here, again, is an example from social networking. We developed this methodology to kind of scientifically determine what the optimal groupings of recipients would be based on the differential disclosure behaviors between different people that users interact with on social networks. And so we apply this method to social networking, and we find the following options. Here on the leftmost side, you see options that are actually hopefully quite familiar to you. Namely, you can share with either your family, your friends, your classmates, your colleagues, and your acquaintances. Right, so this is a typical breakdown, but if you have an application that needs a more granular breakdown, then we ran the same algorithm again, but with a more granular parameter, and that gives us these groups over here. So there's different ways in which you can do these groupings depending on how detailed you want to be. And then finally, there are some other factors that can determine TLA users' disclosure and sharing decisions, right? So the goal here is to measure these to get as accurate of a representation as possible of the user's intention in sharing or withholding a piece of information. Often, the contextual influences on our privacy decisions exist because of the concept of what we call purpose specificity. TLA users, when they are asked to disclose a piece of information or to share something or to deal with a certain privacy setting, they will ask themselves, what does it make sense here for the learning application to ask for this type of data? Does it make sense here for me to share this with this person? Right? So the purpose of that disclosure decision is really important, and that makes this a contextual decision, because in different contexts, different purposes are more prominent. So I want to conclude by saying that measuring preferences is really hard, especially if you want to do it unobtrusively. And I do think that in a learning system where the main task is not to manage your privacy, but to learn things, that this measurement should happen as much as possible in the background, right? So if you want to do this, luckily, a lot of knowledge can be gained from users' behaviors, like what do they disclose, what permissions do they set, how do they use different privacy features, but also, for instance, their personal characteristics, right? What is their age, what is their gender, what group do they belong to, and maybe even the context of the decision. So when is this information being requested and in what context, right? So as a final note, though, I want to point out that measuring all these different aspects of people's privacy behaviors can in itself be somewhat invasive. So we need to actually keep privacy in mind when we are doing privacy measurement itself. It's a little bit paradoxical, but it's important to keep that in mind when you're doing any type of modeling, including privacy modeling. So now we are moving to modeling users' privacy preferences based on the collected information. So I'm not going to go into a lot of detail on algorithms, since it turns out that standard machine learning algorithms work actually quite fine also in the realm of privacy modeling. A main distinction that can be made in terms of algorithms is between collaborative filtering algorithms and case-based reasoning algorithms. And so the collaborative filtering algorithms, they leverage similar other users' privacy settings to provide privacy recommendations to the current user. And so this is actually a very powerful technique. It's probably the most commonly used technique in recommender systems and AI at this point. But one problem is that it may itself fall prey to privacy problems, because sometimes it's possible for a system like this to leak sensitive information about other users' privacy settings through the recommendations that it makes. So you have to be a little bit careful with that. There are actually privacy-preserving algorithms as well, but they don't work that well, so this is a little bit of a trade-off here. Case-based reasoning algorithms, on the other hand, they don't rely on other users, so they don't have this problem, but therefore they are usually kind of static in their behavior and their predictions. So this means that the model doesn't really evolve over time and also doesn't really improve with more data from more users. So another interesting complicating factor here is that while most machine learning research focuses on improving prediction accuracy, I would argue that in user-tailored privacy, it's actually more important to keep the model, the algorithm, explainable and user controllable. So you might have heard of the wonders of deep learning, but it's something that's very difficult to explain and to control for users. So you probably don't want to have an algorithm like that. We really want TLA users to have a stake in their own privacy management. So this means that when we employ algorithms to help them with their privacy decisions, those algorithms should be easy to understand and control. Another interesting aspect of modeling in user-tailored privacy is that the target for modeling is not always very obvious. So specifically, it might seem obvious to try and match the user's current behavior as closely as possible, right? So that way you can alleviate some of the burden of making a privacy decision. But it's also possible to try and find actually the gaps in the user's current behavior and try to fill those. And this would enable the system to solidify some of the user's current privacy management practices. For instance, by recommending complementary strategies that fit their current strategies. Or it is possible to allow the system to help the user to evolve beyond their current privacy practices and really learn about new privacy practices. I would call that privacy self-actualization to a certain extent, right? So here's an example of these different ways of dealing with privacy modeling. So let's say you have a user who frequently limits the recipients when sharing a certain learning outcome. So this could be a selective share, right? So one thing we can do is we can relieve some of their privacy concerns and some of their burden by predicting with whom they will share something new, some new learning outcome, and then automatically sharing with that group, right? That way we are just doing what they're already doing. But another thing we can do is we can solidify their privacy practices by helping this user construct, for instance, useful groups of recipients that they can use repeatedly in future sharing instances. So that would solidify their current practices by adding something useful to it. And finally, we could move beyond their current practices by suggesting privacy measures or privacy mechanisms that fall outside of their current awareness. So now we're teaching them something new. And the big challenge for user-tailored privacy is not to pick one of these, but to combine them and to do that in a usable manner. So there are some other challenges. One thing is we need to keep in mind the privacy paradox, which says that users' privacy preferences don't always align with their behaviors. So the question becomes, should we match their behaviors or their preferences? I think matching their preferences is better, but it may sometimes then conflict with what they're actually doing themselves in the system, which can lead to certain problems. And these problems can be exacerbated by the fact that users are likely to follow whatever recommendation you give them. So if there's any error in your prediction, those errors will propagate over time. Predictions are also difficult when the user is new to a system. And finally, users' preferences will likely change over time. So this means that privacy models should evolve, but also that current decisions should actually take into account future changes in the user's preferences to avoid and minimize future regret. So all of these things make privacy modeling a little more challenging than it might seem at first hand. Now, the best way, I think, to address these challenges is to implement user-tailored privacy as what I call a layered and gracefully degrading system. So layered here means that each of these aspects of modeling, measuring, modeling, and adapting needs to be developed and evaluated separately and needs to be perfectly aligned with the goals in and of themselves before you create a whole system. And gracefully degrading here means that if a certain part of this system fails, for instance, the modeling doesn't work because there's not enough data, then the system should still operate in a non-personalized manner. So it means that the system shouldn't just stop working when there's when the user-tailored aspect fails. Now we come to the point where we're modeling users' privacy preferences to provide adaptive privacy decision support. So this can be done in several ways. The most straightforward method is to adapt privacy settings themselves, either automatically or through some sort of nudge. And as we have mentioned, it's important to take into account the context in which the decision is being made, and also to respect the user's autonomy. So there's actually various ways to adapt settings that vary in how much autonomy we give to the user. On the one hand, we can fully automate, which alleviates a lot of the burden, but it's difficult when, or should be avoided when some of these privacy settings are very consequential because the user is not always in the loop on these decisions. Highlighting is a good alternative there, because while it doesn't reduce the user's physical effort of making the decision, they still have to do that themselves. If you highlight a setting that you want them to have a look at, that actually does reduce their cognitive burden, so that's useful. And then finally, we can recommend privacy settings more actively, for instance, through a virtual agent. And the nice thing about this is that this allows the system to also explain the recommendation, not just give the recommendation, but also explain it. But it turns out that we've seen, and when we tried this, that such explicit suggestions can sometimes be awkward when the recommendation involves a certain potentially socially awkward privacy recommendation, like blocking someone, for instance. And another flavor of this is to change the order of sequentially presented information requests, because the order in which you request things from users can be seen as kind of a de facto prioritization. Now, another potentially useful adaptation is to provide justifications for your suggestions and for your privacy recommendations. And the nice thing about this is that even though you're matching the user's current privacy preferences or practices, by justifying the recommendation, you actually increase the user's trust in the user-tailored privacy system. Now, these justifications themselves should also be tailored to the user, because it turns out that different users are amenable to different types of justifications. And so it's important to get the framing and the timing just right for a particular user in order to be maximally conducive in your justification. Now, this is an area that is still very open to future research, and we're currently working on this, but this is an approach that I just wanted to highlight here. And then one can also adapt the user interface, the privacy setting user interface, so that it becomes easier for the user to make certain privacy settings, right? You emphasize the settings that the user is likely to use, and you de-emphasize the ones that they're not going to use anyway. And so this kind of combines the idea of user-tailored privacy with the idea of privacy by design. So here's an example of this for Facebook, where you may have noticed that pretty much every privacy setting in Facebook has a lot of different privacy settings, but all of them are at least one click away from the main interface. And so the idea here is to selectively bring some of these things to the foreground. So for instance, if you have a selective sharer, you can make the audience selection buttons more prominent in creating a new Facebook post. Or if you have a time saver, you could make timeline moderation more prominent by adding a hide button on every single post on their timeline, rather than hiding that in the drop-down menu of the post. And so you can envision that with these different privacy profiles, you can come up with different ways to highlight different types of interface mechanisms. So another thing, as I've mentioned earlier, is that the best way to do this is to have some sort of privacy profiles. Again, you can try to construct these privacy profiles yourself, or you can do this based on these personas that we talked about earlier, where you kind of extrapolate these privacy profiles from one setting to another by considering the underlying intent behind each profile, right? And then finally, another way to adapt is to adapt the personalization. So research has shown that users of personalized systems tend to differ in how comfortable they are with the use of their personal data for personalization purposes. And because of that, TLA, which does a lot of personalization of this learning experience of different of recommending different learning applications and different learning modules within each application, TLA should adapt the workings of this learning adaptation to the user's data use preferences, so that this recommender of these learning applications only uses the type of data that the user is actually comfortable with it using. And so a way to do that is to use a privacy-enabling user modeling framework, such as the one proposed by Wang and Kopsa. This framework kind of keeps track of which data is being used for personalization for each user. So each user can have a different base amount of data that's being used for recommendation. And an additional benefit here is that this can also be very useful for GDPR compliance, because under GDPR, not every single type of data is allowed to be used for personalization. So here you can have different users use different amounts of data for different users. So finally, some concluding remarks. I'll repeat my one slide takeaway. So learning systems that employ TLA are envisioned to use a lot of learner data to provide learning recommendations and personalized adaptations, and overall a kind of user-tailored learning experience. And so the power of TLA is really into effectively using this data for personalization purposes. So even though this is a privacy webinar, I want to acknowledge that TLA doesn't work without data. However, we need to make sure that in collecting that data, we keep the user's privacy in mind. And I hope that I've convinced you that user-tailored privacy as a means to measure and model and adapt the privacy settings of the system to the user's preferences is a really nice way forward, because it avoids complexity without taking away control. Now, I hope that I've given you some useful guidance in the process of implementing user-tailored privacy in TLA. Some of the findings suggest more than one single solution. If you read the report, you'll see a lot of that. I've tried to pick the most clear-cut ones for the presentation, but there's much more in the report that is a little more nuanced. And there's also some cases where we don't really know the best solution as of yet. So I'd like to use the question and answer time also to discuss some of these points where we don't really know the answer yet, and see if we can all get on the same page on these. So if you have questions, sometimes I'll tell you, oh, I don't really know the answer, but let's discuss. And if we don't have too much time to discuss today, then I also want to point out that you can always ask me questions over email, and we can set up a meeting or discuss over email about these things. I'm very open to input and other considerations as we're moving forward with this work. But that's it for today. Thank you for listening.
Okay. All right, thank you. First question we have from Avram Bart is, once you build a model of users' privacy preferences, how can it be improved over time, e.g. from mistakes or as the world changes?
Yeah, I think that's a really useful question. I think part of that is to kind of model users' preferences with what we would call a sliding window. So users' oldest preferences should be given much less weight than their more recent preferences, right? So as you are measuring this data and this data comes in over time, the more recent data should get more weight than the older data, and that will kind of improve the model over time already. The other thing is to really be cognizant of these changes in society as well as in the system itself. So if the system changes substantially, it means that the rules of the privacy decision are likely to change. So you can no longer rely on the old data that you've collected about the user, right? So this means that you have to be very skeptical towards the data that you yourself have collected. And that's probably the best way to move forward here. One part of this is to, when you decide between whether you want to automatically adapt the system or ask the user, do you want to do this? So more give them a suggestion. The confidence that you have in that decision can be taken into account, right? So if you are very confident about a system, a certain prediction, you can automate that privacy setting. But if you're not sure, because it's been a long time since you've asked the user about this, or because a lot of things have changed since then it's best to actually ask the user about it or give them a suggestion. rather than automating that setting completely. Yeah.
Okay, thanks. Another question, doesn't measuring user privacy-related characteristics and behaviors breach users' privacy in the first place, considering this would be a secondary use of their data, if any?
Yes and no. I think first of all you can account for this, right? You can tell users when they are starting to use the system that this is one of the reasons why their data is going to be used, right? So you can tell them, you know, we are using your data for learning, which is our primary purpose, but we want you to acknowledge, or we want to make sure that you know that this data is also being used to help manage your privacy, right? And I think that's a really important aspect of this, is that, you know, people need to know that this is happening, right? I'm not suggesting that user-tailored privacy should, you know, it should operate in the background in the sense that it shouldn't be in the user's face, but the user should know that this is happening, and they should know that the system has their back, so to say, and that this system is helping them. So that way it becomes actually not a secondary use of their information, but a second primary use of their information. And as long as users are aware that that is happening, I think that is not necessarily a violation. Another aspect here that I would point out is that this probably also makes more sense if you consider TLA or any distributed learning platform as a hierarchical system, where the TLA-based architecture that is managing underlying learning applications is generally more trusted than the underlying learning applications themselves, because the architecture is usually an in-house development. It's usually a concerted effort to try and manage learning applications for the organization that is employing the system. So the overall architecture is kind of one of the good guys, so to say. And so because of that, if that architecture manages this data for privacy, for protecting the privacy of the users towards these underlying learning applications, that is a more acceptable dynamic, I would say, in the sense that, you know, you are allowing a system that you trust to use some of your data to manage the privacy of systems that you trust less, which I think make this dynamic a little more acceptable.
Thanks. Okay, thank you. And this one might not be a 2-minute question. You could probably go on for longer about it, but if you could give us the 2-minute answer of what are some of the future directions of this work?
That's a very good question. I think specifically for TLA, a not too near future direction of this work would be to build some of these ideas into a prototype implementation of TLA. So as we are doing these live tests at Fort Bragg and at other locations, it would be nice to have at least a sandbox version of UTP, of user-tailored privacy, built into this prototype system, or this sandbox system, to try and see how well this works in real life, right? We have tried this out in real life in various prototype applications ourselves. Those were usually either commercial style recommender systems or social networking systems, but not so much learning systems. So the short-term TLA-based future work would be that. I think generally the idea of user-tailored privacy, I think one of the ways forward is to think about privacy not just in terms of how the system settings work, but in terms of what the user's preferences are. I think that's the main key here. I think the real reason why user-tailored privacy is so important is because it's difficult for people to translate their privacy preferences into the settings of a system. And so the ultimate goal kind of user-tailored privacy is to provide a way of communicating your preferences to a system and then have that system translate those preferences into settings, rather than having the user have to do that translation, which is difficult and unappealing and not without error. So that would be the future goal, is to get to a point where you can tell the system your privacy preferences rather than having to set your privacy settings. Yeah.
Great, awesome. That is about all we have time for today, but did you have anything else you wanted to say you wanted to leave our listeners with?
I think we're good. Thank you all for coming.